Welcome to BSc Studies. I am Bala. Today I will explain about blackbody radiation. So here blackbody radiation means it is a perfect absorber or perfect emitter. So here blackbody radiation means, before going to blackbody radiation, what is blackbody? Blackbody means it is a perfect absorber or perfect emitter. Okay, so if I take like this, it is a body. If I incident a beam of light and it is emitted same energy of light, so that is known as blackbody radiation. Radiation that absorbs emits So here blackbody radiation means radiation that absorbs or emits is known as blackbody radiation. So if I take a body like this, so if I incident a beam of light and it is reflected back, same energy of light. Okay, so this is blackbody. And in nature there is no black bodies, and one thing acts as a black body, that is hollow sphere, and it is painted with platinum black. So that acts as a black body. Okay, so this is blackbody radiation. And here another important point. So if I take like this, it is a body, and incident rays are like this, and reflected rays. So here the energy is emitted is not continuous. It is discontinuous. Energy emitted by this black body when the incident ray is fallen, so that is not continuous, that is discontinuous. So if I draw a graph, y-axis, x-axis, so the graph is like this. Okay, so this is blackbody radiation. So on x-axis, blackbody radiation. On y-axis, intensity. Okay, so this is a graph which is made by blackbody radiation. How it is? This means the energy is discontinuous, so that the graph is drawn like this. Okay. So this is blackbody radiation. On the basis of blackbody radiation, one theory, Planck's quantum theory. Planck's quantum theory. Here on the basis of blackbody radiation, he introduced one of the theory, Planck's quantum theory. Here in this, he said that if an incident is beam of light and it reflects, okay, so here the energy is not discontinuous. Energy is not discontinuous. And another point here, energy is released in the form of small pockets or quanta. Okay, so in this he said energy is not continuous, it is discontinuous, so that he can say the graph is like this, x-axis, y-axis. Okay, so here energy is released in the form of small pockets or quanta, like this small circles or pockets or quanta. Okay, so like this he said when an incident ray is passed on this body and the released energy is in the form of quanta or small pockets. Okay, so this is Planck's quantum theory, and he said energy is directly proportional to wavelength, sorry, frequency. Here energy is directly proportional to frequency. So by removing this frequency, he said E is equals to h nu. E is equals to h nu, and here E is energy of quanta. H means Planck's quantum number or Planck's constant. Here this symbol is frequency. Okay, so this is Planck's quantum theory. Energy is discontinuous. Energy is released in the form of small pockets of quanta, and energy is directly proportional to frequency. By removing this frequency, energy is equals to h nu. Okay. So this is Planck's quantum theory. And here in this, h is directly proportional to frequency, and another E is equals to h nu, or E is equals to h c nu bar, or E is equals to h c by lambda. So these are the 4 equations for using in problems. Okay, so here h is directly proportional to nu, and by removing this the proportionality constant and replacing the equals to, h is a constant introduced by Planck. H is equals to 6.625 into 10 power minus 34 joule per second. Okay, so this is Planck's constant. And here energy is equals to hc nu bar, because frequency is equals to velocity into nu bar. Okay, so by replacing this we can say hc nu bar, and by replacing frequency equals to c by lambda. Okay, so these are the equations from frequency, wave number, wavelength. Okay, so these are the 4 equations used in problems. Okay, And here another important point. Here we said that energy is equals to h nu. Okay, so this is for one quanta. This is for one quanta. Here for two quantas means E is equals to h nu plus h nu, which means 2h nu. Okay, by adding these energies we can say second quanta energy, but we should not do like this. This is wrong process. Okay, the actual process is energy is equals to nh nu. Here n refers to number of quanta. Number of quanta. Okay, so this is the Planck's quantum theory. Okay, so after this another theory is also proposed basing on blackbody radiation, that is photoelectric effect. That is photoelectric effect. Photoelectric effect. So here what is photoelectric effect? Before going to photoelectric effect, this was invented by Albert Einstein. Okay, so here photoelectric effect means, so if I take a body and if I take incident ray on this with particular energy, one electron is ejected. Okay, so this has one of the threshold frequency or energy for removing from this metal or any other substances. Okay, so if I take, I am explaining again, if I take incident beam on this and from a threshold energy or frequency, threshold energy or threshold frequency, the electron ejects from this body. Okay, so this is minimum frequency or minimum energy to eject an electron from this metal. Okay, so here another point, potassium, rubidium, cesium. So these are the three metals loosely connected from nucleus. Okay, so these are the three metals loosely packed from nucleus, which means, so if I take like this atomic structure and here this is a electron, this is the gap between the nucleus and the electron. So by here there is a force and here there is a force, centripetal force, and here electrostatic force, which means both are balanced for revolving in a circular orbit for electron. Okay, so that is known as Bohr's theory. Okay, that is a model of an atom. So before going to Bohr's theory, here there is a centripetal force and here electrostatic force. Both are balanced to revolve in a circular path for electron. Okay, so that is electron revolving in a circular orbit. For that reason, electron revolve in a circular orbit. For removing this electron, there is a minimum frequency, that threshold energy, that is known as threshold energy. So the minimum frequency is known as threshold frequency or minimum energy is known as threshold energy. Okay, so this is photoelectric effect. It was invented by Albert Einstein. Photoelectric effect means if I take an incident beam of light and it ejects an electron by threshold frequency another important point, potassium, rubidium, cesium are three metals. When a beam of light is passed, any frequency or any energy, it gives electron after ejection. Okay, so this is photoelectric effect. And today topic is completed. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. If you have any doubts, please comment on the comment box. Thank you.